I can't keep anything straight right now. I'm just like the sun has fried my existence.
That's rough.
Um,
No, it's difficult with that
I
with that
can't keep
weather.
anything strict. Okay, let's see. We'll let it, like usual, I'll let it sit. Um, because I know we're a little late, so hopefully people will.
And I am sharing the screen.
Good.
The wrong
Good.
screen.
Screen.
We'll, we'll get hookups too.
Yeah, we'll get
That's
up.
fine.
I'll put this on my phone so I know what's going on.
Yep.
Whoever wants to join in. If not, we'll be talking to ourselves, which is fine too.
Sure. We'll have fun.
I don't mind talking to ourselves. Oh, what the heck? How did you get switched over? Change my switch account. There we go. Okay. All right. Look at silence. As we're preparing to talk about this week in space weather.
It's been long already.
It's been a long week. I mean, for me, for multiple reasons. I can't believe that we're on. This is the 10th day. Like, and then I still got 14 more, I think.
Oh my goodness.
Yeah. Oh, look at that. There's already people here.
Yeah. Well,
Hi,
shall
everybody.
we?
Oh, like you said, I need a cowboy hat. I can oblige. I happen to have it sitting right next to me.
Oh, that's fun.
Yeah, it took me a second to get this up so I could see who's here, but hello everybody. So sorry, I got the time messed up. Well, I said 8 p.m. and was meaning 8 p.m. Central. And then it was like, oh, we gotta go live. We gotta go live at 7. I have nothing prepared, and I've been out in the sun for 10 days straight, so I'm
You've
a
been baking.
little fried. I don't know how people live down here. Like, these multiple strings of 90 plus degree Fahrenheit days,
Oof.
this full sun. It's a bit much. But anyway, so I now that I realize there's a bunch of people here, is we don't have to sit here and wait for too long. So we'll just jump right into what we're going to talk about today, which is all the stuff that happened last week with excitement with CMEs and streamer blowouts, film interruptions, all sorts of a whole mixed bag of things. And
Exactly.
why we're going to get maybe not like I know the excitement was like, full Halo stuff and this like this, but it ends up being a lot messier than we thought. So that's what we're going to go into. So without
For
further
sure.
ado, I'll pass it along.
Well, we do have some exciting updates. The Swiftlet L1 is on the way to L1. And it is expected to reach L1 at some point in January. It is undergoing in-flight calibration, so some of the instruments are on already, and they're going through essentially verification and calibration steps. Everything is working like it should, which is super exciting. So go L1. Um,
Yeah.
I know, go Swift. It's going to be called Solar One once it actually is operational. So that's going to be at some point in April. But it will be, yeah, it will be exciting. And we have Discover back. Yay! At this
Yeah, I was
point,
going to
it's
ask you
just
about
a
that.
magnetometer. It's just a magnetometer, but the recovery process is underway. So plasma metrics, meaning speed, density, and temperature, will be posted at some point. But this is actually very exciting. It's good to have a backup, even though it's not there all the time and it's not a complete backup, but it's better than not it's just having ACE that goes in and out every now and then because we just don't have a station that can listen to it or some other issue is happening to it. So we do have a backup. Yay! Exciting.
Yay.
I know. No, this is super cool. It's been
I,
a really good good news for space weather professionals because both Solar One, future Solar One is doing very well, and now Discovery is back on track. So it's awesome. All right. So after that news, we had a lot of fun in space weather from that big coronal hole. Mary Beth, I don't know if you have the visual of that coronal hole
Oh, I
because
can get
it
it.
was
I
an
can.
interesting one. It was mapped out as either continuous or sort of discontinuous with one portion that was clearly transequatorial, so it was crossing the solar equator. If you want to pull Suvi from, I would say like 4 days ago, uh,
Okay. Yeah,
or even
I'll do that while you're
even
chit.
5 days ago, but it was exciting because it is the right, so to speak, right polarity for the season. And it definitely had plenty of negative BZ as expected for what was it? Positive polarity, I believe, this time.
Yeah.
Yes,
Yeah.
it was a
Positive.
positive polarity. So lots of negative BZ, intermittent with some areas that could have been transient throw in there. So maybe small CM, flux rope, not really a full blown CME, but definitely intervals of negative BZ, which got us to decent storming. I mean, October 2nd was G3 storming, which was very impressive and a little bit unexpected too. But nonetheless, from that October 2nd, was pretty much continuous nights of aurora. And even before that, but we did have a CME that caused the previous storming, and then we probably just had fast solar wind with onset that was a little earlier than anticipated. So onset really was October 1st. Um, but again, because the solar wind speed was so fast, it was reaching up to I think 700 at some, oh, definitely at 700 and sometimes close to 800 at a few points. It probably had earlier onset than we expected based on the position of that coronal hole. So lots of aurora, lots of pictures, lots of happy people, lots of clouds sometimes, and the aurora that was sort of visible through clouds. You could see the substorms, and like it's so disappointing. But nonetheless, that was fun. And as expected, this was the CME earlier, and then we went straight into that fast solar wind with lots of very decent storming. So substorms are there, but it gets a little tricky. Um, some interesting data thrown in here and there, but we definitely can talk about it, why it's there, why it's not just an error or some sort of instrument glitch, but it could be.
Yeah. I only.
Yeah, this is our what third round of Hiltka at this point. We had a couple in the spring, interestingly enough, from negative polarity coronal holes as expected for the season. Now it's up to this positive polarity coronal hole to produce those long, long, long auroral events. So Hiltka stands for high intensity, long duration, continuous auroral electrojet activity, and you can see it by definition, it has to be in the auroral electrojet plots, and we're looking at AE index. So everything that's bouncing above here, that's where you need to track it. It usually starts with geomagnetic storm, which is right where it started on October 2nd. It was the G3 storming. And typically we see it with high-speed streams with favorable BZ, obviously. It may last several days, and hey, we actually have seen it for several days now. So this is a textbook Hiltka. Auroral electrojet, the AE index need to be above 1000 nanotesla at least once, and we definitely have reached that multiple times actually. Over 2 days duration, it could be shorter because it's sort of the same pathway how we get this prolonged activity. It's that oscillating BZ, preferably favorable for us, not so much for other people and other space weather users, data users. And the auroral, the AE index should remain above 200 nanotesla. Interruptions about less than 2 hours are acceptable because again, sometimes you just don't get a favorable BZ, so you end up with this. But it lasted for quite some time. And usually the more intense activity tends to be closer to the CIR, closer to the onset of fast solar wind, and it sort of dwindles down over time. But it all depends on how things will play out, and some of the decent substorming can definitely happen later. It gets a little tricky because not all of the substorms technically are, not all of the spikes are technically substorms. Because this activity is continuous, sometimes you just get enhanced convection. You don't see a classical substorm in the sense of the growth, the onset with bright, 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 bright aurora, and that slowly diminishes and goes into recovery. Sometimes you get just enhanced convection, and a substorm may happen as it's reaching the peak. It can also happen after the peak. So there's this discontinuity with geomagnetic activity that you see from ground magnetometers and what you see in the sky. And that's pretty normal and typical for Hilka. So expect it if you're using ground magnetometers or anything that's sort of based on ground magnetometers, you can see a little bit of discontinuity here. But that's exception to the rule, and it happens with specific types of activities. So fast solar wind can drive it. Typically, you get a fairly good correlation, but you can get a disconnect during Hiltz events. Kind of fun, but not really because you expect to see something and then you just get diffuse aurora for hours.
for hours.
Yeah.
But I think
So
I think I have that coronal hole up if you want to see it. I mean,
yeah, let's do that. Let me stop
oh,
sharing and let's take a look at the ground hole
let
because
me
it
do.
was definitely interesting shape.
This is probably not the greatest wavelength to use, but I could see it, so I just rolled with it. So it's this guy here. And you can see it's got a really interesting shape
Yeah,
to
you
it.
could, yeah, if you want to go to Suvi 131, you should be able to see it.
It's
And get rid
31.
of the
Yeah.
284. Oh,
It's
eh?
not as good. 131,
No, not really.
but because you can see it all through here. But yeah, it's got that weird like you were talking about, it's kind of like discontinuity to it.
Yeah. So some forecasters were mapping it as continuous.
Yeah.
So some forecasters really were mapping it as two-piece, but nonetheless, it clearly had transequatorial
Yeah,
components. So
it did like right
yep,
through here.
it and it had some very strong wind.
Hmm. Did it get it? Because there was some, correct me if I'm wrong, but I thought I saw well over 800 at one point, at least
Yep,
briefly.
yep.
Yeah. So it was definitely a quick one, but that's the I'll stop that for now. And then I have it up for the wait, do we want to do the eruptions too? We haven't really gotten there
Not
yet.
yet. Hold
Yeah.
on.
I'm glad she's here to drive this right now because I'm like, what's going on?
Oh, we saw some other nasty stuff from that coronal hole because again, with a continuous activity, you get particles kind of accelerated to the point where you start to see lots of electrons and you see protons in geosynchronous orbit. So if you're looking for at those events and thinking, well, maybe it was an eruption somewhere that increased protons, because that's one of the things we typically see with very energetic eruptions. They send tons of protons our way. Nope, this is all from geomagnetic activity alone. So
That's crazy, right?
it is crazy because
Yeah.
this is not fun for satellites. They experience internal char and external charging from all those electrons that are just basically getting on to and creating a charge in satellites. And sometimes, well, if you build up the charge, you have to lose it somewhere. So you can have discharges. And that can definitely do some damage to the satellite. But most importantly, those protons, they're not super high energy, but they still can create some issues um, too. So errors and malfunctions in the devices can happen. That is not the same as having solar particles coming in. So we usually don't get to see them going all the way to the ground. But people who are in orbit right now,
Mhm.
they could be seeing this a little bit too. So it's an extra dose of radiation that's more in like ISS. We would probably worry about them. Again, this is sub S1 level, so it's what's called soft. It's lower energy and it's not as damaging, but nonetheless it's there. So kind of fun thing what geomagnetic activity can do with our
Yeah.
own trapped radiation belts. Ugh.
Yeah, I like to bring it up too because I know, when everybody looks at these types of or like even EPAM chasing and stuff like that and noticing that the Earth can add to that.
Yeah. Oh, definitely. Ew. That's what we're talking about. So
Next, it was
CIR,
good.
yeah,
Yeah.
like perfect timing. Right on
Let into
cue. We
that.
got EPAM data. So this is CIR acceleration of the particles. And it is a shock. It's moving through. And it usually doesn't peak as high as what we see with CMEs. And also the source of particle is very different. Doesn't resolve as quickly. It just can go for days as long as the solar wind speed is elevated. You could see those energized particles. And what's interesting about this is if you think about where particles are coming from, with the solar flare and CME, so when you see EPAM that is rising ahead of the CME arrival, those are particles that are coming from the sun. So that's the source of those particles. They were accelerated very close to the sun and they're being carried over by the shock. Those particles are, with CIR, they're local. So they just happen to be there and they get picked up and they get accelerated. So they're actually going with a shock from CME. They're coming in from the sun. So they're going away from the sun. Those particles are actually driven backwards.
That's pretty
They're
well.
getting pushed toward the sun, usually on sort of the that shock pair, the forward shock and reverse shock. So this is reverse shock creating all of this. But if you think about it, if you have a river that's carrying leaves, that
Hmm.
essentially is kind of the CME accelerated particles. Those leaves travel with the current. And when you have a pond and you drop a stone in it and there are some leaves on the surface and you start to see leaves going in the different directions, that's how CIR shock works. So there are particles that happen to be there, they just got picked up and accelerated, and sometimes they're thrown in the opposite direction. You also see those bursts that are likely originated in the magnetosphere or where solar wind meets the magnetosphere. And again, those are directed from the magnetosphere or the border of solar wind and magnetosphere, the boundary. They're directed from Earth, essentially, toward L1. And when the solar wind density is very low, um, L1 satellites can pick it up. It can sort of throw the data off, so you get aberrant readings. Normally, there is a correction in place for this, but when the density is very, very low, it's going to be very difficult to correct. So you start to see kind of funky data in solar wind. Density is all over the place, speed is all over the place. It's not necessarily a data error. It's created by real data. It's just the program that's supposed to resolve this and correct it is really struggling because the density of solar wind is so low.
Makes
So
sense.
yeah, it's not necessarily data glitches. The data is real, but the data is not necessarily all solar wind. Where
Fun time.
exactly those particles are
Yeah,
accelerated is still debatable, but it's kind of fun. So yes, they're sort of they look glitchy, but it's real data and it can happen. Usually, again, when the density is low, you start to see a lot more of those events.
good to
All
know.
right. And
Oh,
lots of aurora.
yeah.
So I don't have pictures of aurora from the ground. It's all just aurora from space. So September 29th, September 30th, October 1st, October 2nd, October 3rd, October 4th. So
This is painful.
this is all aurora. It's and you can tell that the location of where it is slightly different too. So if that allows me to go, no, it will not allow me to go anywhere. Ah, don't do this to me.
I watched it through webcams for days.
Yeah, oh, same. I caught it in my backyard, but there were literally like 20 pixels of aurora. I didn't post it anywhere.
20
Like
pixels, like that's it.
it's like green and pink
Yeah.
in between the trees and yeah, no. But it with every night it's sort of moving, it's kind of inching further toward the poles.
Yeah.
Because very slowly we start to lose the IMF, we start to lose the strength of the magnetic field. So there's just not a whole lot of it that can go into BT, and it's harder to build up a decent substorm to move it equatorward. So in our case, move it south. For the southern hemisphere, that would be it's harder to move it north. But nonetheless, like several solid nights of aurora. I don't know how many hours people got of of sleep people got over this last week. Probably not that many if you're really chasing aurora and have to work on top of it. My heart
Yeah.
goes out to you. That was a rough week. I'm really sorry. No, not really. I'm jealous.
It was,
If you caught it, I'm very
yeah.
jealous. And I'm very happy for you. Yeah. So this was again last night. Again, it's UTC time, so it was early morning, a little bit of aurora,
Oh,
lots
look
of
at it.
clouds.
So
Yeah,
little.
it's like aurora here,
It's so
but it
little.
still was there. So we started with CME. We had coronal hole CRR HSS, and if you what's called transients, you can't really tell what the source is. It sort of looks like CME, more like a flux rope, but it's a period of persistent negative BZ that was sufficient to increase activity. So that was a lot of excitement. But
Yeah.
sort of take home from Hilke event, it usually results in several days of aurora. It starts with geomagnetic storm, so anything that's G1 or higher, and it continues as ongoing enhancement. You can see sporadic substorms out of the background of already enhanced aurora, not really enhanced aurora, but more diffuse aurora. And again, geomagnetic activity may not necessarily follow what you see in the sky during Hilka. Sometimes you just see more convection happening. So those electrojets, the currents that are responsible for or get enhanced, but you don't get a substorm. You just get this energy dump into ionosphere without building up to a substorm. And again, this is more likely to be seen with large coronal holes because you need several days duration of that fast solar wind with favorable polarity for the season. And that coronal hole is coming back, so we may get
Yeah.
more
Yeah.
Hilka out of it. We're still close to the equinox and it's still favorable polarity for the season, so we may not be done with it yet. We just have to see how it survives the next rotation and what it looks like when it finally comes back. If it's a long duration, if it's sort of long coronal hole and has transequatorial component, I think we might be seeing Hilka again. Unfortunately, again, it's locked with a full moon. It's getting slightly asynchronous with a full moon,
Yeah.
so it's preceding the full moon, but that's still a lot of moonlight. So that's that's my spiel for
Nice
Hilka, and we
skill.
can move
Yes.
on to solar events in the forecast. Are there any questions?
Um, Try to think. Well, the only one that was in here was, did the protons help discover backup? And I'm like, probably not.
No. No. Discover is at L1, so we're
Yeah,
not looking at protons doing anything, and there's no official word as far as what actually happened with Discover, but
right.
getting data from it is very exciting. So it's the
Yeah,
I think it's going to be recovered fully. Um, I mean, plasma metrics from it were not exactly reliable in the first place, but it would be good to know at least what the speed is.
yeah.
Um,
At least
So
it's like something.
yeah,
So that's because
exactly.
I know
Exactly.
for a while it wasn't looking great. So it's nice that
Yeah,
it's
I know.
coming back. So now I guess we can talk about our current events. So I will share the screen because I have Helio Viewer up. Helio Viewer. Da, da, da. So this was the thing that caused the all the excitement. Well, in between, it was funny because it was in between all this Aurora going on, and then the sun decides to do more. So it just made made for an exciting week. So I'll just let this loop through. But well, try, it's a little fast, but it kind of started with that guy right there. What was that? It wasn't a super big one. It was an
M
M1, right?
1.5.
Yeah, 1.5. And it had a CME with it. I mean, it's like central disk basically. Um,
If you want to, do you want to switch to 195?
Yep.
Possibly. Yeah. There you go.
Yeah. So let's see, because yeah, this one shows because this was the filament up here, right?
Mm-hmm.
So had the filament lift off, the flare in the middle, and then the other thing that which Tiny will show is the streamer blowout event because that's the third thing three, I think is what we're talking about.
3 and 4.
Yeah, so we have four different CMEs in the works here. I mean, none of them are really big. They're
I would
called
say four, yeah, four different
yeah,
eruptions.
they're pretty slow. But needless to say, there's four of them. And then I'll let this play it for more times.
Mm-hmm.
So you can kind of see what's going on here, and then we'll talk about how they got to the forecasting end of it because none of these were forecasted really to do much, and we'll get into as to why that is. So we'll
Yep.
stop that.
All
I'll turn
right.
it back
Let
over.
me go to Solar Demon for this one. It will be fun. So that is a Solar Demon is have we shared that before? I
Yeah.
think so. So Solar Demon is more of automated detection of dimmings and flares, obviously. Let me change things just a little bit. There we go. That's better. Oh, I want this. Yeah, there we go. So it looks at 211 angstrom for SDO. Yes, it's getting SDO data despite us not getting it, which is,
Right.
again, jealous. But it derotates the sun a little bit. So sun continues to rotate and detection of dimming becomes a little tricky if you just follow it as it rotates. So it derotates it, it corrects for that rotation and kind of accumulates all the dimming that um, has been going on. Dimming means something is leaving the sun. So in this case, there was this central dimming right there, and it was followed by that filament eruption. So this one is a little on the faster side. This one was a very, 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 very slow event.
Yes.
Filament eruption wasn't any faster. Um, all of those events are very slow, and I'm going to stop sharing and I'm going to
Mhm.
try to find stereo images from this.
Yeah. Yeah, because that shows the CME is pretty good.
Yeah, I don't have, so this is, I think, CME 1 and 2 possibly right here. I don't have a video, so you'll have to imagine that this
Yeah,
thing
that is
is
moving.
actually going, and stereo is looking at a slight angle. So Earth is actually somewhere here, and this is based on where it started and based on where it's going. And stereo is obviously on the Earth facing side of the disk. And it could be a combination. It's like the combination of two things. It's likely more of the central eruption and the filament that was in the northeast of the sun. And this one is a streamer blowout. So it's very wide. It's creating kind of rarefaction behind it. So it's fairly dense. It took hours for it to erupt. I'm I'm sorry, I don't have the video, but it really was sitting there for quite some time before it finally took off and went to Earth, probably because it
Yeah,
was so close to the center. So
right.
which one of them created a halo? It was a very complex signature because so many things were happening at the same time. It was extremely difficult to model for forecasters because it's hard to tell, and sometimes attribution of which chronographic signature. So what exactly in chronograph belongs to what event on the disk becomes very challenging. So
Hmm.
forecasters kind of did the best they could. And I'm gonna go back to this actually. I do have a few other things to share.
Go for it.
That's what I'm doing.
The more the merrier.
Yay. All right. And I can share more of the visual, but this was a filament eruption. Again, one of the CMEs, earlier CME,
Yes, yeah.
and it wasn't directly caused by M15 flare, but it was related to it. It was a filament that probably got disturbed enough to leave the sun in because of that flare, but it was in the northeast part of the sun. Very slow. This is slow for CME.
Yeah,
442 kilometers was used for modeling speed. It could have been slower in some parts and faster in other parts. So M2M, Moon to Mars, NASA forecasting office is predicting arrival sometimes on the 6th with the usual margin of error. So something to look for. That's one. They did not model any other CMEs,
okay.
either because it was a lot of uncertainty as far as where they started and where they going, but there was no other CME that was modeled as having art directed component. M2M was a little bit more inclusive. They modeled both the flare related filament eruption and the filament eruption that happened later. Low confidence for the initial filament eruption in as far as arrival. So they have it going way eastward,
Yeah.
just in the opposite direction, maybe a glancing blow from that. But the other filament eruption is high uncertainty as far as timing and the possible impact because it is so slow. Forecast, pretty much everything is possible. Could be G1, G2, maybe some G3 storming. Can't tell when, can tell whether or not that forecast can improve its certainty, although I think we can cover that part too.
Yeah, yeah.
And this is Whipsy. So two CMEs, slow moving, sometime on October 7th.
So they're going even
So
longer.
they're going with even slower speed.
Yeah.
And when CME is erupting at a very slow speed, the slow solar wind behind them will actually accelerate them. We normally think about CME erupting, their energetic events, they're plowing through slow solar wind like a snow plow. Well, this one has to be dragged over.
It's
It
actually
is
kind of
so
pushed.
slow. It's got brakes fully engaged. It's not going anywhere. It's getting pushed from the back, but by the ambient solar wind. That's how they get accelerated. So if that is happening, you can predict a couple of things. You can first of all predict that it's probably not going to generate a whole lot of shock. So may not have a signature in EPAM. It's going to be hard to know when it's coming. It probably not going to be super strong either. I mean, there
Hmm.
are exceptions to the rule. Obviously,
Yep.
you can get 10 nanotesla enhancement, which not going to do that much to drive aurora um, kind of to mid latitudes. You're going to get something out of it, but you're missing a big part. You're missing that sheath that is essentially folded and compressed ambient slow solar wind prior to the CME. So you're gonna miss that part of storming. And it definitely adds a bunch to overall storming with CMEs, but for slow ones, your only hope would essentially be the whatever flux rope it in favorable position for the CME. So, and that we have no way to predict, but we'll have to wait and see. And finally, I think that's kind of final for the modeling that I pulled into
Mhm.
a slide deck. This is Huxt. So it has two CMEs in the forecast because they do use M2M modeling, and there is very high uncertainty. It's
Yeah.
going to arrive at some point.
At
So
some point
this is
over those
CME
2 days.
1
Yeah.
over the next couple of days.
Yeah.
This will arrive at some point over the next couple of days. The speed that they use for modeling is really slow, 428 and 330. And when you look at that and you look at the arrival speed, you see that the arrival speed is actually faster than starting speed.
That's wild.
They're not slowed down, they're actually accelerated by the solar wind. But look at the timing when it could happen, when the arrival could happen. And that's because they're so slow. They're harder to model.
I'd say.
Yeah. So over the next couple of days, we may see an arrival of a couple of CMEs. Are they coming? Well, this is where Solar Orbiter could be really helpful. Um, Again, those things arrive without a label to Solar Orbiter or to L1. We don't know which one is arriving, but there are two arrival signatures. So this is one. There's a little bit of enhancement.
Mhm.
So it is likely one of the four candidate CMEs. Which one? Good luck. If you can figure it out, let me know. I'll be happy to take your word for it, but we don't know. This is likely another one. And Solar Orbiter currently is in fairly good position to be a guide, mostly for reducing forecast uncertainty. So we have a few CMEs in interplanetary space between Earth and Sun. If Solar Orbiter is close enough, and it is close enough actually, so it's separated by longitude of about 3 degrees separation longitudinally, 9 degrees separation in latitude. It's close enough where it's helpful. Um, but will it predict what we're going to see in terms of solar wind? No.
It
So
just
will it
shows
predict the
something, right?
arrival? Not exactly.
Yeah.
So ultimately, we will see it when they show up at L1. So bottom line, several slow CMEs, moderate certainty thanks to Solar Orbiter as far as their arrival, at least for two. We have to wait a little longer for the other few to actually show up in Solar Orbiter, and that may happen over the next day or so. Still high uncertainty in arrival time and very high uncertainty in impact. Likely not major because we don't see huge enhancements in solar orbiter, and normally CMEs lose some of that magnetic strength as they travel um, toward L1. So over time of their travel, they're losing steam, so to speak.
Mhm.
And as usual, L1 will have the final answer.
Yes, it will. So we
Yep.
wait.
So yeah, so we wait.
But today is the 5th. So therefore,
Next 3 days.
next 3 days we shall we shall find out.
Yeah, it's gonna be virtual chase because the full moon.
Yeah, that too. We have a full moon coming in. So
Yeah.
if this isn't really expected to be anything big, which it likely, I mean, I don't want to say no, but things are pointing towards nothing major, then yeah, the full moon is a hindrance for us down here. Um, the Arctic regions, like I always say, it's not as much of a problem up there, but um for
They
us,
get aurora every night,
yeah, they get
almost
in.
every night.
So that's a moot point. That's why I always I like to always always laugh a bit at all these like tourism sites and they're, 2026 is going to be the greatest year ever for this. And it's like, well, yeah, you can do that, but you also can go whenever, no matter what, in the Arctic, and you'll see it. Solar
Yeah,
night.
as long as you have night hours in the
Yes, yes.
Arctic.
You can't go in the summer. And then there's always the weather problem.
Yeah.
So you might get blocked by clouds, but that's neither here nor there. But I think that's pretty much all we got. I don't think we have any outlying questions in the um oh yeah, big moon and cloud competition. Yeah, I haven't looked at the weather to be honest. I mean, I could tell that's one of the things it's been pretty good up there lately, but I'm sure that's going to change soon because
Yeah, it's changed. We have a cold front going
yeah,
through,
because that was
so
good.
it's
The other thing about last week was the weather was really good up there too. So like at least
yeah.
for a lot of it. So
Yep.
that's always nice. But yeah, I think that's it. So hopefully you guys got something out of this and our analysis and forecasting. Even though I said we aren't going to do forecasting, but it's there. We might as well talk about it because everybody else is talking about it. So, hello.
Yeah, it's definitely not shaping out to be a May 10th event. Even
No.
though there are multiple CMEs on the way, they're not energetic. They're not going to drive the same degree, the same magnitude of impact. They're very, very slow. So it will not be a G4, G5 storming. And
So,
it's not going to be, yes, October 10th and October 8th storms. Everybody remembers that, how
uh-huh.
spectacular they were. This is not the same level.
Yeah. So I'm just responding. I
So,
guess I keep forgetting. I'm like typing. I'm like, I could just say it. I could just say it. So instead of typing, I would say, thanks everybody for being here. I'm glad you got something out of this instead of me typing like an idiot. Sometimes I kind of forget that there's like this disconnect. So anyway, all right, cool. Well, I'll let you all have your evening back. Thanks for joining.
yeah.
And again, it's nice to have people that really want to see this because I'll tell you, like after 10 days in the sun and then I still have 14 more, it gets kind of hard to like be motivated to do this sometimes. So I appreciate you all being here. And hopefully like you guys will see some maybe some aurora if we get something halfway decent to outpower the moon. So anyway, thanks. And we'll come up with something next week. I'm sure we will.
Yep.
So
Well,
maybe
I'm sure.
an analysis of this whatever's coming.
Yes, I think that would be a good one.
So there we go. So without further ado, I'll let you guys have your evening back.